My name is Vardis Tsontos from the NASA Jet Propulsion Laboratory, and in my presentation today, I'm going to give an overview of the coverage project and also the prototype data platform that we're putting together that will enable improved, more integrated access to interagency satellite and in-situ oceanographic data, including animal telemetry data. Coverage is a formal initiative that's led by NASA within the Committee on Earth Observation Satellites, which is a coordinating body between the various space agencies involved in Earth observations. It is a cross-cutting and collaborative effort involving various agency partners. The motivation is to enable more widespread integrated use of interagency satellite data in support of ocean science and applications for societal benefit, to address key constraints to access and synergistic use of multi-sensor, multi-parameter Earth observations, particularly amongst emerging communities with the need for such environmental information. The actual goals of the project are to implement a technology platform providing access to complementary satellite and in-situ datasets from distributed sources and provide value-added data services on top of those. We want to provide improved access to a coherent, curated set of global interagency data products from the 4 ocean virtual constellations, so sea surface temperature, ocean vector winds, altimetry, and ocean color radiometry at a common quarter-degree baseline resolution, with a focus on supporting higher resolution data sets next. But we don't only want to put together a technical system, we want to demonstrate the utility of the system and approach in the context of a pilot thematic ecosystem application related to high seas fisheries and biodiversity in relation to the environment. Coverage has adopted a phased development approach. In December, we completed Phase B, which was implementation of a prototype system, and in June, we kicked off on our 18-month Phase C project. This slide summarizes the distributed data architecture that was implemented during our coverage Phase B project in support of our current ecosystem thematic pilot application. We have 2 satellite data nodes hosted in cloud computing environments at AWS for the NASA data and US datasets, and on EUMETSAT's WIKIO system for the Copernicus Marine Environmental Monitoring System satellite data products. Both cloud nodes also host our full software stack. In addition, we are connecting to in-situ data providers, in particular providers of animal telemetry data from IMOS and CSIRO in Australia, and the US IUS Animal Telemetry Network in the US. We're also integrating RFMO catch and effort data from the 4 tuna RFMOs and fishing AIS vessel positioning information from products provided by Global Fishing Watch. The coverage website and prototype data portal are available online at coverage.ceos.org. The website contains descriptive information on the coverage initiative within CEOS and our project. It integrates a range of prototype data services and tools that I'll be describing shortly in this presentation. There is also a resource area with project technical documentation, tutorial videos, and other materials that would be of interest. There is also a news area where we post frequently on events and announcements pertaining to the coverage project. We have a coverage YouTube channel and Twitter feed that you can follow. And we have also integrated Google Analytics into the website, so we have very detailed metrics on usage of the website and its various pages and features. Last time I checked, we had more than 1,000 users accessing the site from more than 77 countries. So there appears to be quite a bit of interest in what we've put together thus far. Coverage prototype data services include an advanced web-based data visualization capability. This allows integrated visualization of both satellite and in-situ data of different types, including gridded data sets, point, profile, trajectory, time series, and station type geospatial data. It allows synchronized horizontal and vertical views of data and their evolution over time. The tool also provides very precise control of the time intervals through which a user steps through and visualizes data. Included in the tool is also an integrated dataset search capability that allows filtering of listed datasets by parameter, platform, program, and other variables. Included in the tool is also a one-stop data subsetting capability that applies to both satellite and in-situ datasets being visualized on screen. The software is based on JPL's Common Mapping Client, or CMC software, which is an open source development. In terms of future work, as part of our Phase C activity, we plan on refining some of these capabilities, but also including new ones, such as the integration of analytics capabilities in the tool that will allow summarizations to be performed on both satellite and in-situ data, and also for co-location operations to be executed. The figure shows some representative graphical output from the visualization client software tool. On the panel on the top left, we see IATC Big Eye Tuna archival tag data in relation to spatial catch distribution information and Aviso sea surface height environmental information from satellites. You can see that not only are we plotting the horizontal distribution of these data as maps, but we can also see in the charts adjacent the detailed depth profile time series from the archival tag. In the figure on the bottom left, we are using the tool to visualize sail drone ADCP and CTD data that are overlaid on satellite sea surface salinity data, and that we can step through over time and look at various types of plots, including correlation plots between different parameters, depth profile ADCP plots, and time series of surface measurements of salinity and temperature. Finally, the panel on the bottom right illustrates how users can select different data layers for visualization interactively, and then use the tool to explore data and then select regions and time periods of interest for data download of both satellite and in-situ data layers that are selected. This short video clip shows usage of the tool to explore some IMOS animal telemetry data in relation to satellite data layers. So we can filter and select our in-situ data layer, do similarly for the satellite data layers. We can view metadata on any of the data sets to help guide our selections. We can step through time series dynamically or animate through them. We can set up charts for the different in-situ data variables available. In this particular case, we're looking at archival data from the elephant seal, depth versus temperature, and similarly salinity data. This is for the daily bind data available through IMOS. And we can step through time. The black bar illustrates the time period that we are focusing on, which corresponds to the bold area along the track, and we can step through. The link to the complete demonstration video is provided above. There you can see other examples of animal telemetry datasets that we can visualize via this tool. And you can see more detailed descriptions of some of the features of the tool, particularly as pertain to the charting capabilities. Coverage also includes prototype analytics cloud data services. This is via JPL's Science Data Analytic Platform software, which is an open source development under the Apache Foundation. SDAP essentially enables big data science without download. It allows computing operations to be performed via both Jupyter notebooks and through APIs close to the data repositories themselves, thus not requiring data download or significant movements in data. We've currently implemented SDAP as part of our software stack on both Coverage's AWS and EUMETSAT's Wikio cloud environment. This allows users to undertake queries, primarily of large satellite data sets, very efficiently in parallel form across these different cloud computing environments in a consistent manner. Prototype data services also accessible via the coverage website include a dataset search capability. This integrates dataset metadata from multiple agency repositories, including NASA's CMR, or Common Metadata Repository, FedEO, which is the European Centralized Metadata Repository for Earth Science datasets, including from Copernicus Marine, the Australian IMOS, and CSIRO-Marlin metadata systems. Features of the online form include keyword-based search and faceted search filtering of listed datasets. Results that are returned include dataset description and access point information. Coverage places particular emphasis on community and stakeholder engagement aspects because we really want this development to be community-driven. So over the past year during Phase B, we've been involved in numerous consultations with our various stakeholders. We've presented at several conferences, and we in fact have had 3 workshop events, including at Ocean Sciences and at ESIP. Coming up for Ocean Sciences 2022, in February, we will be having a consultative workshop, and we hope to see you there. In June, we embarked on our Phase C follow-on project, which is an 18-month activity. Elements of Phase C will include continued community and stakeholder engagement, further hardening and extension of our prototype technical capabilities, more emphasis on higher resolution data sets and support for forward and near real-time data streams. We also want to expand on our thematic applications, developing a couple with a more regional focus. Part of the activity also involves development of an operationalization concept and sustainability plan for coverage. And we also have submitted an ocean shot concept to the Ocean Decade US for engagement within the UN Decade of the Ocean, relating to next generation data service infrastructures for digitally integrated ocean observing system. And we will be pursuing that further. This concludes my presentation on coverage. Please contact us if there are any questions. Check out our website and follow us on Twitter for information on future events and news. Thanks very much.